All right, welcome back. So, we'll pick up where we were a few minutes ago. So we are trying to get this first test working, where we have some HTML. There's a button in it with a on-click event, and we're trying to simulate clicking that and get the sample message out. So we did have this test passing, and then we dug in to discover a bunch of changes that have been made in the virtual DOM library in elm-html-test, and discovered there's a bunch of differences in how the options for the stop propagation and the prevent default are handled internally in elm-html in Elm virtual DOM. So we added this test where we now have a button that uses the stop propagation property, and we're trying to click that and get an event. We haven't had this one pass yet, and the code, the suspicious code we're looking at here is this native code where we grab the event handler or the event decoder out of the virtual DOM node itself. So what I just realized from this is maybe we shouldn't be returning the decoder at all. We should maybe just be returning the handler. We could just return a type that basically looks like this, and then we could deal with everything on the Elm side of things. So that might be the way to go. That, I think, would actually make this easier, and all of this conversion and mapping of decoders we could just do on the Elm side, and we would have type safety for all of that. So I like that idea. Let's give that a try. So basically, we're going to return the event handler instead of the decoder. And we saw that here, basically this, let's see, where is it? On. The handler is basically the thing that we have. The handler is of this type. And this is a private type, right? Oh no, this is actually exposed from virtual DOM. Oh, that's perfect. Okay, so we don't even have to redefine this type or define our own type. We can just use handler directly from the virtual DOM module. And then we don't have to do any fancy manipulations in the kernel code. We're just going to return the handler that we have in the object. Okay, this is going to work way better. So we're going to dump all of this code, and instead we're just going to return the handler itself, which is event.a. We should maybe put that into our key value. So let's add value here, which is apparently the letter A. And this is virtual DOM kernel constants dot value. And just to double check, yeah, I'm not actually sure if that's what this A represents. I think it is, but I could be wrong about that. Okay, so then this is going to return a handler. So the place where we called this, which was here, I still have my search up, this is now going to be event handler, and this does not return this at all. It returns a virtual DOM.handler. And now I guess all these compile messages we just had moments ago, we're going to have to track through again. And we need to import virtual DOM. Okay, and that also means we need to depend on that module. So where are we? We're going to need to go to the elm-JSON here, and I guess we can let the command line tools do it for us. Let's do npx elm, not elm package anymore, just elm install and elm-19, elm virtual DOM. And I'm pretty sure we can safely open the version boundaries to go all the way back to 1.0. Whoops. Great. And I'm thinking we'll probably also need to add this to the elm-JSON in the tests, but I guess we'll wait until it tells us we need it. Ah, great. Okay. And handler needs one message, or excuse me, one parameter, which is going to be message, because previously we had a decoder of message. And okay, so now we're on line 108. This will also be virtual DOM handler of message. And line 111. Okay, what is the problem here? Second argument to map is not what I expect. On 111, event decoder produces what? The event decoder call produces a handler, but map needs the second argument to be a decoder. Okay. I guess that's because tagger function doesn't return the right thing. Wait, so what is actually wrong here? Let's look at some of these others first. Oh, these are like all on the same line. Okay, let's look at the first one. Okay, line 26. Tagged event decoders. This tagged event decoder value, I see, is a function that returns a handler, but decode elm-html needs the first argument to return all of this stuff. I see. Decode elm-html actually needs to return a decoder in the end. Internal types. Decode elm-html. So that's here. Yeah, okay. So this needs to be the virtual DOM handler again, and we'll deal with that internally. And we need to import that. then internal types line 204. Context decode elm. Okay, so then HTML context also contained this function. So this now will also get the virtual DOM handler. Then line 442. The facts. Okay. And then facts also, I think, changes in the same way. We're going to have a dictionary of handlers now instead of just decoders. And we can always produce the decoder from the handler. It's just it also contains other stuff about the options. Okay, so I think we're on the right track here. Let's look at, oh, are both of these the same? Okay, these are both in the same place. Decode events. So let's look at that. This, I'm not sure what this event handler means, but I think we still want our handler here. Or do we? I guess so. Ultimately, we're still decoding this stuff. So here's the point where, I see. We actually need the decoder at some point. So we're actually turning it into the decoder. Okay. So I think this is maybe the point where we need to turn the handler into a decoder. So this is going to take a handler message and give a JSON decoder with all these options. Though I guess at this point, maybe this is the point where we could just drop it back down to message for the moment. And now this will become the point where we drop the options. Let's try doing that, I think. I feel like I'm kind of going back and forth on all this stuff. Oh wait, but this is supposed to give us the events, so we're still supposed to have the handler here in the dictionary. So what does that mean? I'm not entirely sure what that means. Okay, so on inert line 111, the event decoder call produces a handler, not a decoder. Yes, that's true. And we actually don't need anything about decoders here. Looks like what we really need is a virtual DOM or a handler map. I wonder if that exists in the virtual DOM library. Let's see. I'm guessing probably not, so we should be able to write this pretty easily. Handler. Yeah, okay. So we need to write a map handler, and we're going to use this here instead of JSON decode map. Okay, that's making sense now, because this function now returns a handler instead of a decoder. This also returns a handler instead of a decoder. So we shouldn't be doing anything with decoders. So map handler is going to take a function from A to B, and take a handler that produces A's and give us a handler that produces B's. All right, to implement this, we need to case on the handler. We know we've got normal, all of these basically. Let's copy them from here. Okay, so in the case of normal, we have a decoder. We're going to JSON decode map F on the decoder and produce a normal handler with the mapped decoder. For may-stop propagation, we will JSON decode map with the function. Actually, we need tuple.map first with the function and the decoder. Then may prevent defaults. This is going to be the same thing. We have a decoder of tuples, and we want to apply our function to the first item in the tuple, and then produce a new decoder that applies mapping the function over the first item to whatever value it produces. Okay, so that'll be the same. Then custom is essentially the same thing. We just need to map the single value. So I don't think we'll be able to curry, but this pattern is essentially the same. We're going to map with some function, which is the value. We're going to return the same value, except message will now be f of value.message. All the other fields will stay the same, and we're mapping over the decoder. Okay. So I think that should fix this problem. We just needed a map function for that. Let's see what's left. Oh, and all of these are virtual DOM dot whatever. And same thing here. Makes it a little messy, but nobody should ever need to fix this function. It should be correct. It should stay correct. Okay, so what did we do wrong here? Line 130. The F call produces a B, but it should be an A. Oh, I see. Okay, we can't actually use record extension to change the type of the record. So we actually need to reconstruct this whole record in here. So we will have stop propagation equals that, and prevent default equals prevent default. Okay. Cannot find, oh, and these are both value dot. Okay. And I'll format that in just a second. Okay, and it looks like that worked there. So now we're on to event line 303. And event decoder. Okay, so now I'm going to ignore the messages because I kind of know what's going wrong. So we just changed this dictionary. This dictionary now contains virtual DOM handlers instead of decoders. So this is the point where we need to, so the get will give us a maybe back because the key might not exist. So we're going to do maybe.map, and here is where we need our handler to decoder function. And this, okay, this is making sense. So we're going to get rid of this, and where we're actually going to drop the extra options right now is going to be here in our handler to decoder, which let's add the type annotation. This is going to take a virtual DOM handler, which can produce message, and it'll give us a JSON. Oh, looks like we have decoder already imported. It'll give us a decoder of message. And this is where we're putting our note. We're going to drop the information about the options. And now we can case on the handler. And now, instead of trying to do this in the native code, we can do this in Elm, where we have all of our nice compiler safety checks. So we have normal, which gets a decoder, and this is just the decoder itself. We can check the type. So normal, we have the decoder we want. Great. Let's add the rest of these. Whoops. Okay, so these are all from the virtual DOM module. Great, so here we have a decoder of bool. So we're just going to take the decoder, decode.map to tuple.first. So I'll make a decoder that just gives the first value out. And same thing for here. And for our custom one, basically the same thing, but we're just going to get the message field out of there. Okay, let's format that. And see if it works. Virtual DOM handler. There we go. And okay, we've never imported that. Import virtual DOM. All right. Oh, okay. So both the tests passed. We are throwing an error because test.only was used. Okay, great. So I think we can clean up some stuff here. We can get rid of all this. We can get rid of logging this. We can get rid of this import. Okay, so that all seems great. Let's go and stage this stuff that we like. So we're getting this. This all looks fine. We fixed this to use the correct value. We also noted we want to move these into constants. I'm wondering if we should just do that now. Let's leave this comment uncommitted, and we might do that in just a moment. Okay, so then in all these internal types, we're now storing handlers in our internal representation instead of decoders. Okay, this line we can put back on a single line. Internal types, 447, somewhere around there. Here. Guess we should format again before we stage everything. Okay, that's just that comment. Okay, so we imported that, changed this to handler. Oh, okay. This is wrong. This comment's wrong. So I guess this should be virtual dom.normal with a JSON decode.succeed unit. Okay. Yeah, okay. I don't see any helper functions in here that let you create handlers easier than that. But this function is only for use inside of this package, so this is not a public API, so I think that's fine. So we will add that. These comments I'm just going to go ahead and add, and we change the decoder to handlers in here. Also imported virtual DOM, changed things to handlers. We had to add a map function for handlers. That all looks good. Then here, okay, we can get rid of that debugging. Okay, so this dictionary is what we changed to have the handlers, and then we wrote this function to convert the handler into a decoder. And this is the point where we have access to all these options, which currently elm-html-test doesn't expose to the people writing tests, but there's a future issue to use that. So this is where that's going to happen someday. Great. And then we have these onlys. So let's uncomment the onlys. And actually, I'm realizing we're missing some tests. We did not add a test for the stop propagation or the custom. So let's add that real quick. So here, stop propagation, this is prevent default event listener, and that should still pass. Yep, no failures. This is blowing up because of the test.only. And finally, we want custom event listeners, which we want custom on. What is the name of that function? If we go to HTML and it's just called custom. It takes a string, it takes a decoder of all this stuff. Okay. It's just called custom. Where does that come from? HTML events, I see. Okay. Custom seems pretty generic. I'm just gonna refer to it explicitly. And here we make this record. Message equals sample message. Stop propagation equals true. Prevent default equals true. Okay, let's format that. And now, oh, hey, that didn't format. Okay, something must be wrong with my syntax here. Yes, okay, so that matches, this matches. There's just too many parentheses. Okay, great. All right, no failures. So let's get rid of these onlys and format this. And we'll still have a bunch of test failures, but these, this first one at least is passing, and then these these three more that we, that we added. Also are passing. So we've got test coverage for all this option stuff, which is great. So let's see where we're at. Oh, great. So we are down to only 4 failures on mapped keyed events, it looks like, and mapped lazy events on mapped HTML. Oh, okay. So basically all of the mapped stuff looks like it's failing. Okay. And this we'll put back also. Format on the tests. And while that's running, let's finish adding this stuff. Okay, so we added some new tests for all these options. We just reordered those. I'm going to go ahead and commit that. This, I think VS Code is just creating this for some reason. And this we definitely need. What I'm unsure about is why we didn't need to add this in our elm-JSON for the tests. Is there even an elm-JSON for the tests? There is. Oh, I see. We already depend on Elm Virtual DOM as a direct dependency in the tests. Okay, that's why we didn't need to add it to tests. And this we're not committing. And we're down to 10 failures. Okay, so let's commit this. And the description of what we just did was update event virtual DOM event handling code. Event handlers are now virtual DOM handler instead of json.decode.decoder. Cool. All right, let's take care of this refactoring real quick. Move these constants. Let's just make sure nothing else imports this. So we've got internal types that uses it, and what is helpers? Helpers imports it, but doesn't seem to use anything in here. If we delete that, does everything run fine? Known keys, I see. So known keys is the... Oh, interesting. Filter out keys that we don't know. Okay. So this is actually just listing them all. Okay, I guess maybe that's not useful. I'm not really sure what this filtering thing is for, but I'm just gonna leave that alone. Great, okay. So let's see if we can get the rest of these events tests working today. And I think we'll probably call it there, but it'll probably take a little while to get that working. So it looks like there were these tests about mapped HTML. Yeah, here. Okay. So is this the first one that's failing? Let's see. Let's see if this one fails. Yes, okay, so that one's failing. And the problem here is it can't decode. There's no such type as for. All right. Okay. So these are all ones that we haven't run into tests for, and I'm guessing that this tagger one, like tagger is a term that's used in a lot of the Elm internal native code to describe like functions that transform message values. So I'm guessing that all this virtual dom.map stuff is going to use these tagger nodes. So I'm guessing this is going to be type 4. What do we have in here? We've got K, which K looks like it's just a virtual DOM node, because this is a button, and this is type 1, which here is a type node. And then B, I'm not sure what B is. Let's check the kernel code for virtual DOM and check out what this does for map. So there's map attribute. Is there just map node? Here we go. Okay. So tagger, I'm guessing this is type 4. Then the tagger itself is going to be a function, so it doesn't show up in the JSON. Then node, so we saw a single node, and then we saw a number, which descendants count here is 1 plus the node's descendants count. The button's descendants count as 1, so it looks like that matches up. So I think this is 4. If we run this, I guess now we'll probably run into more failures. So here, decode tagger. Great, and we marked this, and probably this fails because I'm assuming this field name is wrong. Expecting object with field name tagger, but the tagger field is now this, which we don't actually know what it is. We'll have to dump the value from JavaScript to see that. And then we have this, where there's a bunch of different kinds of nodes in here. Looks like this is always called node now. I don't see other types of fields. Let's take a look in the elm-18 code real quick. Huh, yeah, this was the same thing here in elm-18. So I'm not sure why this then looks for multiple types. Okay, anyway, we need to figure out what the field name is for this when it gets compiled. So I think the only way I can think of to do that is we need to spit this out when we transform the HTML into a JSON object. So let's see. So I guess we have to dig into here a bit. So we are at e sub 0, console.log HTML. Oh, actually here it is. E is an array, sub 0 is this, and J is the field name that has the function. Presumably that's the tagger function. So this is going to be virtual DOM constants.tagger, and we need to find this and add tagger equals J. All right. And then it's expecting an object with field named custom, or with field name text, or with field name node. Yeah, and I'm pretty sure it's always going to be node. This is virtual DOM constants.node. And I don't think those are necessary. If they are necessary, we need to find out what the field names are. Yeah, so there's no field name called that corresponds to custom. There is one called text, but I don't think it's ever going to be used in these tagger values. Okay, so what happened now? Test failed because it threw an exception. Type error is not a function. Okay, so that's unfortunate. I am wondering if there's a problem here. I'm not really sure where to look. Let's just guess and see if this is getting called. Console.log tagger, and maybe tagger is undefined or something. Oh, and we can remove that one. Oh, interesting. Okay, so this is actually an object now. So we call map, and we get tagger. This actually looks like it's a JavaScript or an Elm object of some type, which contains a function. I'm curious if that, like the virtual DOM handlers, is something that we have exposed. So let's just check on that first. So here we call map. This just takes a function and a node, and we get the function and the node. Huh, okay. So I'm not really sure why this is a whole object, but it seems like we can fix this just by calling a, or getting the a field, which is actually the function. I don't really understand why that's necessary, but it seems like it'll work. Yeah, okay. Great, and that test passes now, and test.only was used. So let's remove that and see where we're at. Okay, 2 failures remain. Returns messages for mapped keyed HTML and mapped lazy HTML. Interesting. Okay, so I guess let's do the lazy one first. This one. Okay, so this is failing. And the problem is in this value EKK. All right, so we got to look up what K was again. K is node. Okay, interesting. So this looks like it's nested taggers or something like that. Okay, so let's print out this whole thing again. And I guess actually we want to print the thing .e sub 0.kk. If it has it, I guess that might throw problems before we get to it. Shoot. Okay. So I thought we were only running that one test. So what's going on here? Yeah, we should only be running that one test. I guess just this is getting called recursively. Okay, that makes sense. So I guess we can say if HTML E and HTML E sub 0 and HTML E sub 0.k, then we can log. Okay, and it is undefined. So what was K itself? So K is of type 5. That's our thunk. Oh. Weird. Okay. So I guess this actually is the stuff that we commented out. I'm not sure what M refers to. Maybe M refers to custom. But also we didn't see anywhere where custom gets used in the native code. So I guess to be safe, we should just stick these in. I don't really understand where these values come from. It seems like the native virtual DOM code is doing things where it like produces objects, but then at a higher level, it like merges objects into fields on a different object or something. If we put M here, actually, let's try just with the text one first. But text up here we saw is A. Actually, I wonder if that's not correct anymore. The A might be referring to something else. So Evan was mentioning these are supposed to be in alphabetical order, which would mean text should not come first. I guess we have C and D. Okay, those aren't in order. Okay, it must be the file order. Okay, so that still fails there. If we turn this one on, does this work? No. Okay. So what do these three mean? We're decoding the button. Which is here. This is of type 4, which is the tagger. K is the node field. I see. So this is the branch about text. So that's fine. So when it tries to actually decode the real node, it is looking for an object with type $. Oh, okay. So maybe we are just digging in, we're not digging in far enough with the at. Like we get a $, of type thunk here. Wait, which one are we printing again? We're printing K. Okay, let's print e.0 and .k and .k.k. Okay, so here's our button. Well, it contains the button ultimately. Wait, where does it even say button in here? So this is of type 4, which is a tagger. It's containing a thunk. Oh, I see. And then it's the cached value when the thunk is evaluated. Oh, okay. So what's missing, I think, is the thunks aren't recursing in through the taggers. Or we had this code that we worked on last time. Yeah, here we go. Okay. So this is the function we use to pre-evaluate all the thunks and cache them in the virtual DOM. So that caching process of evaluating the thunks is not operating through, like when it hits a tagger node, it's just stopping and not recursing. Okay, so we're gonna have this, and when vnode.$, now is virtual DOM constants dot node type tagger, which we have learned now is 4. Then we want to cache the node field, which is the same as this. We want to use this and call force thunks on the node that's inside of the tagger. Okay, and then what was this last part about? If it's node type thunk and there isn't a node already. Okay, so that, I guess we can put that in too, so we don't double cache this. Actually, no, there'll always be a node. sorry. Okay. For the thunk type virtual DOM values, the node starts out undefined, and we save the cached value there. For tagger type values, the node is always there, and we just want to call force thunks on it and store the new value. Okay. Hopefully that'll work. Yeah, okay, so that passed. Let's uncomment the rest of these and see how this goes. There might still be one problem, or that might have fixed both the problems in the events tests. One failure. Okay, what's this last one? Oh, right, the keyed HTML. Okay. So this mapped keyed HTML. So this has sample mapped keyed HTML. We have a keyed node in here. Yeah, interestingly, we didn't find any other tests about keyed HTML yet. So I think we haven't fixed the code for that. So we have this other keyed node type, which we don't know what it is. Which one is it? No such type as 2. And what are we looking for? The key here is key. Okay, so here's the key. Dollar is a pound sign thing. Okay. So what are keyed nodes supposed to look like? Oops. Is that in another module? Keyed node. Okay. Oh, here it is. Keyed node. It has a tag, it has facts, kids, namespace, and descendants count. And I guess the facts are, oh no, oh okay, so the kids are a different format. Got it. Okay. Well, I'm debating if we should backfill a test for the keyed stuff in the queries tests, but we do have a failing test here, so let's go ahead and fix that. So we're thinking this is type 2 now, and where does this get used? It calls decode keyed node. And we've got tag, which is now virtual DOM constants.tag. That should exist, right? Yep. Okay. And that's C, which lines up. E is kids. E. Descendant count is B, so those all match up. D is facts. Okay. So it looks like those are all the same values that we've already discovered. Virtual DOM, this was kids. This is facts, and this one is descendants count. Okay, and I'm wondering, this is maybe changed also. I'm expecting we might get a failure on this decoder for the tuples. Decode second node, that's inside of kids. Expecting a, where is this? Okay, in JSON E, problem with the JSON value at kids sub 0. Dollar is hash sign 2. Is hash used anywhere in here? No. Okay. That's interesting. I'm curious where those values come from. Source virtual DOM keyed node. So it doesn't happen in here. It just calls keyed node in the native code. It has an A field called key and a B field that has the node itself. Where is it getting that from? It's got kids. Kids starts as an empty array. We're getting kid list in. So this is the list of tuples. Oh, maybe that's just the tuple constructor. Okay. Elm stores keyed nodes as tuples. We only want to decode the HTML, the second property. Okay, so that means all we care about is the B field. So I think that should just be B. And needs to or should be tested in queries.elm, but is not yet. Okay. Hey, great. Okay, so that passed. Before we start cleaning everything up to commit, let's just turn on these example tests, and maybe those pass now, or maybe there's still some remaining problems, but we're down to at least the last test file. Six failing tests. Okay. So that's interesting. Like none of the unit tests, there's like failing tests in the examples test that none of the unit tests caught. But I guess that'll be our last final thing to look at. Hopefully in our next stream, maybe we can wrap this up. Okay. So what did we do? We added taggers. We uncommented this. I guess that also means the other remaining commented code here. Okay, that already has a correct comment. Okay. And this debugging can go away. Done with all that. So that we want. We force the tagger thunks. We fixed this. I still don't understand why this was stored as an elm value instead of just as a function directly. We just cleaned up that import. We handled keyed nodes and tagger nodes. This is one of the field names that was needed there. This comment is no longer relevant, so we have fixed that. Whoops. Decode options. Okay, this is not tested by events, and we saw there was no publicly exposed way of getting the options, so I'm not sure why this is even here and why this is used. We can probably delete that, but that'll be a separate commit, I guess. Decoding a tagger. So did we determine that we actually needed these? So we had 6 tests. And we did actually need this, apparently. No, okay. We didn't need that. We still have 6 failing tests. And if we comment that out, everything passes. Okay, so we tried putting this in thinking that it was maybe the problem, but the real problem when we were doing that was that the tagger's lazy code inside of tagged nodes was not correct. Okay, so I think we don't actually need these, and then we don't need one of. This can go away, that can go away, and this is all tested. Then we can reformat. Okay. So that's good. Whoops. Oh, that was too much. Then, okay, we updated that comment. This is B now, which is correct. And those are all correct. Okay, cool. And this still keeps appearing for some unknown reason. Great. So we are now down to 6 test failures. And they're all in the example test, which is interesting. So that seems unusual to me, but we will save that for the next stream. There'll probably be another weekday evening stream. I haven't looked at my calendar, but probably Monday and possibly Thursday again is when I'm going to try to get back to this. And yeah, like I mentioned earlier, hopefully we will get this elm-test library fixed up pretty soon, and we can move on to some hopefully more entertaining projects that are not this like deep dive into the internals of Elm. So let's see, whip down to 6 test failures, and here we fixed event handling when map, lazy, and keyed are used. Great. Okay. So I think that's going to be it for today. Let's see. Looks like there's a few people streaming online right now. So let's go raid Zorkenheimer. He is working on building a NES game from scratch. It's like a running game. He's been designing it for the last couple weeks. But let's go raid his channel. And thanks everybody for stopping by. I am going to, I don't know quite what the schedule will be, but sometime during the next week I'm going to be trying to do another stream, and hopefully we can fix up the final tests for this. And yeah, as always, you can follow me here on Twitch to get notifications when I go live, or follow me on Twitter to try to get some advance notice of when I'm going to be streaming some of this stuff. But hopefully we can wrap up the rest of this project pretty soon. So especially thanks to all of you who have been following along for the last couple of weeks. Oh, hey Richard, welcome to the stream. I guess you caught the tail end. Cool. And Sherry, yeah, thanks for tuning in as well. I guess it's late in Germany, or at least evening. So yeah, cool. Let's go grab, whoops, okay, I gotta refresh my dashboard here. And, oops, okay, we got lots of tabs we can close. Enjoy the closing of the tabs. Cool. Well, thanks again for tuning in. I'm going to put up the closing screen, but hang on in the chat if you want to go raid Zorkenheimer with me and watch some, I forget the name of the processor that the NES used, but if you want to watch some homebrew NES cartridge development, hang on in the chat and we will be raiding Zorkenheimer in just a minute. So thanks for tuning in, and I will see y'all later.